Assalamu alaikum. My name is Rashid. I'm an engineering student, and I wanted to show you the ratio theorem, how easy it is. So the ratio theorem is normally used in position vectors. So when you're given position vector, you have to know that each and every position vector is from an origin. So position vector always are from origin. So suppose we have 3 points. We have a line and we have 3 points as shown. So let's call this point A, let's call this point B, and this point C. Assume that this line is divided in the ratio of m is to n. So since A is the position vector at this point, B is the position vector at that point, and given C is the position vector at that point, therefore remember that so all of these points are coming from an origin O. So when you're given position vector, normally position vector is from an origin. So all of these points are originated at that point. So just put an origin for you to come up with this equation. So let's prove it. So assuming that vector OA is vector A and vector OC is vector B, just assume that are our vectors. Therefore, how do we get vector B? For any, the ratio theorem is used to determine vectors. Using the ratio theorem is used to determine vectors, position vectors, which are unknown, which you don't know. So suppose that we don't know the vector OB. How do we get it? Using the normal formula. Getting vector AC. First, you have to get vector AC. How do we get vector AC? So vector AC is just we can so you are moving from A to C, but since we don't have the vector for here, we don't know, and vector, we know vector is the magnitude and direction. Is when we don't have the magnitude, we don't know the distance, whatever, and we don't know even the direction. So we have to use the way which we know the distance, the magnitude, and direction. So we know for here, we know that we have directions. So since we have the directions and we have magnitude, then it's therefore easy for we to use this way. So let we use this way to come up with vector AC. Therefore, vector AC is just vector AO plus vector OC. Since we are reversing the direction, therefore this one becomes negative A plus B, vector B. Therefore, this one is vector AC. So, since we have vector AC, therefore, it is possible for we to obtain vector AB. So, vector AB and BC is simple for we to obtain. Since the ratio is m is to n, therefore, A, it will be AB, it will be just m over m plus n, multiplied by the total. So, vector AB, it will be just equals to what? We just take vector, we just take m out of the total is m we just take m. The total is m plus n. Then we multiply by. So it is advisable for you to start writing an expression like this with the positive value, then followed by the negative value. Mathematically, it is advisable, but it's not wrong for you to write it as it is. So this is vector AB. That is vector AB. Since now we have vector AB, is now possible for you to obtain vector OB. And remember, position vector is vector from the origin. So position vector of B, it will just be, we just take OB. So instead we go OB, we can move OA, then AB, since we don't have this vector here. Therefore, vector OB, now, vector OB is just equals to AO, which now we haven't reversed the sign, it just remains positive, then plus vector AB. Since we haven't reversed the direction of AC or AB, therefore just remain plus M all over M plus N, then into B minus A. So since you haven't reversed the direction, therefore our vector OB is just vector OA plus AB, where OA is just A and AB is here, then you add that vector. So opening the brackets, so opening brackets, this just equals to what? So OB, it will be just equals to what? So vector A plus M all over M plus N multiplied by vector B, then minus M over M plus N multiplied by vector A. So taking the LCM here is just M plus, therefore vector OB is just equals to what? The LCM, it will be M plus N, therefore, but since here M plus N divided by 1 is just M plus N, then you just multiply by A, which equal A into M plus N. Then here is just 1 when divide, so plus MB, vector B, this should be vector A. Then we just divide it here also, this divide by this, just 1. Then when we multiply it, just remain M into A times vector A. So let's open the brackets. Therefore, OB, it's just equals to what? M multiplied by M, which is M vector A, then plus N times A vector A, plus M B vector B minus M A vector A all over M plus N. We can see that we have MA, M minus MA. Therefore, these two cancel out, and we remain that for any vector that you don't have, for any position vector, you have been asked to determine its magnitude or its whatever. So it is possible for we to say that that vector can be given by either N vector A plus M vector B all over M plus N, which is the same as you write it as M vector B plus N vector A all over M plus N. Hence, we have proved that that vector for any position vector given a ratio of 2 points or 3, therefore this is the method. It is the simplest way to determine the position vector of any point given a ratio of m is to n. This normally that is when you are given a ratio of m is to n. So you should just apply. So meaning that m and n is the ratio. So you just take m multiplied by, when you come here, it's just taking m multiplied by vector b, vector of O, C, then you take n, you multiply by this vector, then divide by the sum of the ratio. So if you want more videos from my channel, just subscribe. So, and I want you, when maybe you are interested with my video and you want more videos from me, just I'm waiting for your comments so that I can improve what I'm giving out. So thank you very much and welcome to my channel.